finally I'd like to discuss a little bit in Chapter 4. In Chapters 1, 2, and 3, our primary purpose was to figure out techniques to analyze circuits. In Chapter 5, the primary purpose of Chapter 5 is to come up with more techniques to analyze circuits. The difference between Chapter 5 and Chapters 1, 2, and 3 is Chapter 5 is going to analyze the same circuits we can already analyze, but with some more clever techniques. Chapter 4, though, is different. Chapter 4 stands out, and in Chapter 4 we're introducing a new component. So we're going to have a new part, a new thing we can put into our circuits. In Chapter 1 we have the resistor. In fact, day 1 we introduced the resistor. That's one piece of all of these circuits. We have the battery, another key piece. We have different kinds of power sources, current sources, voltage sources. We have dependent sources. And in Chapter 4 we're going to introduce a specific component that will be particularly handy. We're not going to introduce that many new components this semester. In Chapter 4 we're going to introduce something that we're going to call an operational amplifier. In Chapter 6 we're going to introduce capacitors and inductors. So we do have these three components we're putting in here. To actually construct modern circuits, you have to introduce more components. Most modern circuits rely very heavily on transistors and diodes. So these are non-linear components. They're harder to analyze. We've gotten a peek at diodes this semester a little bit. We are not going to analyze transistors this semester in this course. So we're not introducing very many components, but in Chapter 4 we are introducing a new component. Let me tell you what it does, and then we'll see in lecture and in lab why this is useful and why I think it's definitely worth introducing in a first semester circuits class, particularly for the non-electrical engineers who, the electrical engineers of course will see these different components for 3 more years. So the non-electrical engineers though, you might see this once, it's a useful component, you're likely to encounter something like it at some point in your career. So it's good to see it in Chapter 4. A resistor has 2 terminals, means 2 ends. So to explain what a resistor does is, in a sense, an easier job. For a resistor, all I have to do is say that the voltage across the resistor equals the current through it times the resistance. I'm done. This device that I'm putting up on the board right now has 5 different terminals. It doesn't just have 2 ends. It has 5 ends. So I need to label these 5 ends and explain what the different pieces do. This side is the output. This we'll call V+. This we'll call V-. These 2 lines are often omitted. The reason they are often omitted is this is the power supply, the positive voltage power supply provided to this little device, and this is the negative power supply provided to that device. So I could call this positive V power, for example, and negative V power. That's, if you leave these 2 wires disconnected, think of the device here as being unplugged. A resistor requires no power to operate. This device does require voltage or some power source to operate. So you have to plug it in to make it do anything. Okay? So that's what these 2 wires are doing. What does this device try to do? What this device does, so I've now labeled the 5 terminals. What it does is it compares these 2 voltages. If V+ is bigger than V-, it tries to take that difference and multiply it by infinity and put that on on the output. So if V plus were 5 volts and V minus were 3 volts, it would take the difference, which is 2, multiply it by infinity, which would be infinity, and it'll try to put infinity at the output. How good a job will it do? How close can it get to infinity? Well, that depends on what your power supply is. So when you plug it in, suppose I plug it into a V plus of 15 volts and a negative of negative 15 volts. And I place 5 volts at V plus and 3 volts at V minus. Then the output is going to be 2 times infinity, which is infinity, but it can't get all the way to infinity. You want to take a guess of the closest this can get to infinity in its current state? 30, good guess. You're looking at the difference between the two. And Ryan's saying 15. He's saying the most positive voltage it can maybe be able to produce is 15. Both good guesses. Ryan's correct. So it will get to about 15 volts. Now, it won't even quite get to 15. It'll get to like 14. Okay. But for all, unless I specify otherwise, assume on an exam or a quiz or a Smith, which we'll do in a moment, that it will just get up to the 15. Right.
Why would you want to do that though? Because if you're just going to output as close to the 15 as you can get, why wouldn't you just plug that straight into output?
Absolutely would. There is no point to the circuit yet. If my goal is to get 15 volts, this is a bad way to do it.
What is this called?
This is called an operational amplifier. That will lovingly be abbreviated to op-amp. So we will call this an op-amp. What if this was 3 and that's 2? Someone want to make a guess what you think the output is going to be in this circumstance?
Close to 15.
What?
Close to 15.
15, Ryan? 15, Isaac? Okay. I agree. 15. How about 2 and 3?
Negative 15.
Negative 15, correct. Okay. So what if I change that from negative 15 to a 0?
0.
Then this will produce 0. And what we mean by an output of 0 is 0 volts compared to our reference. Which reference? Well, the same reference that I'm using to say this is 3 volts. So V minus is 3 volts compared to some reference. V plus is 2 volts compared to some reference. This 15 volts is 15 volts compared to that same reference. So the output voltage will be that same difference compared to whichever reference I'm using for this whole circuit. James?
Say if the V plus and the V minus were the same number, then would the out always be 0?
No.
No.
Suppose they are the same number. This is, in most of the applications of this, we'll see, not today, but probably Thursday. Most of the applications of this involve these two voltages being the same. I'll discuss how we make them the same and how we make that useful, but any number times infinity is infinity, except for one case. That is 0 times infinity. 0 times infinity is kind of like the best defense versus the